What's happening, dogs? Mr. Allen here. We're going to be writing some polynomial functions in factored form and sketching a graph for each one of these two descriptions here. Now, these descriptions are kind of broad, so our answers will vary, right? It could happen a couple different ways, but I'm going to give you guys an example of each. I like to start with the graph in these situations and then write a possible function to go with it. So this first one, we have a double root. We have an imaginary root, which we know imaginaries come in pairs, right? So really we got a double root, imaginary root that's 4, right? Degree of 4 already. It's at least a quartic, and a positive lead coefficient. Okay, so if it's a quartic at least, we'll go with that, and it's a positive lead coefficient, it's going to have sort of like a W kind of a shape potentially, right? A double root's going to bounce off my x-axis, and imaginary will not cross through it again. So what I'll do is I'll start with my double root, bounce off, I'm going to come up, and maybe put a little bend in it right there, get that sort of W shape, right? If it had 4 real roots, one of them being double, I would come back down through and back up, okay? And I would cross through a couple more times. But because it's imaginary, it's not going to cross through the x-axis again. So let's write a possible one here. Let's just say, it's at, like -2 there, okay? And then let's say we'll figure out our y-intercept here in a little bit. I like to actually write my function before I get the y-intercept, okay? So we'll say that it's p of x equals, I know this is going to be x plus 2 squared. That's how we get the double root. That's how it bounces, right? It's bouncing off of x equaling -2. And then to get some sort of an imaginary root, how do we do that? Well, imaginaries are going to come from square rooting negatives. So what if I write a factor where I have like x squared and then let's say plus, 5, right? If I were to set this factor equal to 0, subtract 5, square root, I'm square rooting a negative, right? I'd get the two imaginary solutions there. Cool? And I have a positive lead coefficient here, so we're good. What would my y-intercept be? Just in case we're asked to give us the y-intercept. Well, if I plug in 0 to my function here, I'm going to have 2 squared is 4. 4 times 5, that's 20. So we'd have 20 up here. So y-intercept, that's going to be 0, 20. Beautiful. All right, next example over here. We got the real root, one real root this time, an imaginary root. We know that comes in pairs, right? So a real root, imaginary root, a negative lead coefficient. So what's my degree going to be? Whoop, 3. Very good. You see, that was a magic trick. Okay, so we got a degree of 3 cubic function. I know it's like an n or, the other way. Well, if it's a negative lead coefficient, it's going to be going down, okay? So one real root. So I can either do my little bend above first or after. I'm just going to take care of the real root first, and then we'll do something like that. Cool? All right. Yay. So now, let's see here. We'll say we can do p of x again. It's a polynomial. A lot of times you'll see like p of x when we're dealing with polynomials. Let's see, this one here, we could say like 1, 2, 3. So I'll have, x plus 3 as one of my factors. Ooh, we did say negative lead coefficient. Negative. All right, there we go. And then let's see here. How am I going to get my imaginary? Well, I could do the same kind of thing here. I'll do a different number just for fun. Let's say it's x squared plus 2. Cool? So there we go. I've got a cubic, negative lead coefficient. Sorry, it's a little, almost forgot about it. We remembered it, right? And then what would my y-intercept be so I can plot that? Well, I have negative here. 0 plus 3 is 3. And then I have positive 2. So we're going to get what? -6. So y-intercept, that'll be 0, -6. So I'll go ahead and say that this right here is 0, -6. Cool. And a lot of times we'll actually put this as 0, 20. Put an ordered pair up there. You could scale it up to 20. You could write the ordered pair and plot the point. Either way is probably okay and acceptable, but I'll put the ordered pair. So there we go, guys. We got ourselves the polynomial in factored form, even did the y-intercept, sketch of the graph. That's awesome. Again, this one could have been like I could have done this instead. Let me do I could have been like, woo. That would work too, right? That's still a negative lead coefficient. Cool. And in this case, though, I'd have like x minus some number, like x minus 3 instead, okay? So there we go. That's awesome, man. Good stuff. Fantastic stuff. Lovely. That's all I got on that one. Have a great day.